Welcome, physical science students. Today we're going to talk about how to do an experimental design diagram. Now, right in front of you here, you can see a paragraph that explains what took place in a lab that a student did. Now, the thing is that this is a paragraph, and sometimes these can be much longer, but who really has time to do all of that? What if there was a quicker way to get a synopsis on what was going on in this lab? Well, there is, and it is called a design diagram. So, what exactly is a design diagram? Well, a design diagram is a way to organize and summarize briefly what is going on in an experiment. So, let's find out how we do this. So, the first thing we want to do is we want to read the experimental scenario. Basically, it's the story of the lab, and we want to boil it down to its most important parts. And so the first two things we want to identify in the lab scenario are the independent variable, or IV, and this is what the scientist changes, or what the student who is doing the experiment changes. He can be a scientist or she can be a scientist too. We also want to identify the dependent variable. This is what changes because of what the scientist changes. It is also the thing that is getting measured. So if you are measuring something in an experiment, that is the dependent variable. So now, moving on to step 3, we want to see what this design diagram looks like. So it is going to take the following form. First of all, we have our title. This basically tells the reader what the lab is about, how the IV affects the DV. We then move on to the hypothesis, and this is what the scientist thinks is going to happen. So if the independent variable changes in some way, then the dependent variable will change in some way. It is an if-then statement, and it needs to be specific. You want to say what you actually think will happen. Then we make a little table, and on this table we have our independent variable, and we'll just write down what that is right here. This table has 3 rows. The second row includes the level of variable. So this is the different, these are the different ways that the independent variable is being changed. And then the next row includes the number of trials. These are how many times each way is being tested. Now beneath that table, we write down the DV, where we just state what the dependent variable is, and we also put down the units if that's appropriate. And then finally we finish with the constants. In any experiment there must be many constants, things that you keep the same, so that you can be sure that the independent variable is the factor that's causing the change that you are witnessing. So let's do an example here. Let's go back to that original lab scenario that I was showing you at the beginning. And step 1, as I said before, was read the scenario. So let's take a look at this. Alright, so this one they call Let It Snow. And Randy is a very experienced snowboarder who has been sponsored by Burton for 3 years and gets free decks and bindings from them each year. Randy loves his snowboard and wants to find a brand of wax that will ensure him optimum performance during races. Randy decided to test 4 brands of wax, labeled Wax A, Wax B, Wax C, and Wax D. To begin, he applied 1 thin coat of wax brand A to his board and rode a chairlift up to the top of Squaw Valley. He measured a 500-meter course and rode his board straight down the hill without turning or slowing down. He then recorded the time in seconds it took to reach the finish line. Randy repeated his experiment 10 times for each type of wax. So, let's take a look at making a design diagram for this. So the first question that we need to ask, let's go back to the instructions that were given here. Identify the independent variable and identify the dependent variable. So again, the independent variable here is, let's move this up a little bit. The independent variable is what Randy changes. Randy is the scientist here. So what does he change? He changes the different kinds of wax. He tests 4 different brands of wax. So that is the independent variable, the brand of wax. Now, he's going to ride his snowboard down with each different kind of wax, and he's going to measure something. And what he is measuring is how much time it takes in seconds to reach the finish line. So he's recording the time in seconds. So that's our dependent variable, time. And I'm just going to put in parentheses the letter S to stand that for seconds, meaning we're measuring in seconds. Okay, so now we've done step 2. Now we want to go to step 3. Step 3 is putting all of this into a form that is nice and short and easy to look at and get a quick understanding of what's going on. So like I said, we're going to start with a title. And the title has to take the form of how the independent variable affects the dependent variable. So we would say how the brand of wax affects the time it takes to snowboard down the hill. Okay, notice again I've included my independent variable, brand of wax, this is the IV, and I've included my dependent variable, the time. You don't have to have the exact wording on that, but you do have to have your independent variable and your dependent variable. And if you say how, blank affects, that is another good way to do it. All right, next up, we want to put in our hypothesis. And this is, again, where we are going to state what we think is going to happen. And we want to include, again, both the independent and the dependent variable. And this is going to take the form of an if-then statement. So I'm going to say if Randy uses brand A wax, then he will make it down the hill in less time. All right, again, I'm taking a stand here. I'm saying what I think will happen. I don't know which one is the best, but that's why we do the experiment, to find out. If I'm wrong, it's not a bad thing, but I'm making a prediction. And so, again, brand A wax, this is the independent variable here. Less time, that's my dependent variable. And again, I made it an if-then statement. All right, moving right along. Now, the next part of this, we want to make our table. So, like I said before, our table should have 3 rows. One where we state our independent variable, which we already said was the brand of wax. Our second row will include the level of variable. And so, when I say the level of variable, I mean the different ways that we're doing the experiment. So we're doing it 4 different ways. We have brand A, brand B, brand C, and brand D. And those 4 different levels will tell me how big to make my table. Okay? Since there are 4 different levels, it's going to have 4 columns. All right? And then the last row here, I want to say how many trials I do of each one. Well, if I look up here at the last line of the experiment, it says Randy repeated his experiment 10 times for each different type of wax. So I'm going to put 10, 10, 10, 10. He did 10 runs with each kind of wax on his board. All right, next up, we want to put our dependent variable. Our dependent variable in this case, again, as we stated, is the time in seconds. Pretty simple. And then finally, we want to write down our constants. These are the things that stay the same. So we might have to go back and reread here. Let's see if Randy keeps anything the same. All right. Randy is using the same snowboard every time. So the snowboard itself is a constant. He measured a 500-meter course, so he goes the same way every time, the 500-meter course. And is there anything else? He rode his board the same way every time. I'll just put riding style. You could maybe put it in your own words. And is there anything else? I don't think he says so, but if he did it all the same day, you could probably figure out that the weather might be the same. And again, if you put some thought into it, you can probably think of some more things. But this is our finished product right here. This is the design diagram of Randy's experiment. It's got a title, a hypothesis, a table with the independent variable, the different ways it's changed, how many times each brand is changed, and then finally the dependent variable with the units and the constants. All right, now I think you're ready to do your own, so good luck.